Module 2, Transformers and Load Types. Lighting used to be easy. You screwed in a light bulb. It usually only took one person, unless you needed someone to bring the ladder, and someone else to hold the ladder, and someone else to bring the beer. With the proliferation of options, it's no longer simple. There are different types of breakers, powering different transformers, converting high voltage to low voltage for different load types. It's absolutely imperative that they all function well together. Transformers are generally found in or above the fixture. They convert line-level voltage, usually 120, 240, or 277, to low voltage, typically 12 or 24 volts. There are two types of transformers: magnetic core transformers, or iron core transformers, or the newer, more efficient, electronic state or solid-state transformers. Magnetic core transformers are the older of the two transformer types. They are required for forward phase dimming. If used with reverse phase dimming, it could cause current spikes and damage to the dimmer and/or the transformer itself. It is a lower cost and has a higher wattage output, but is not nearly as energy efficient, and the transformers themselves are heavy and bulky. Magnetic core transformers are very common in some markets, but they're slowly being phased out for the more energy-efficient electronic state transformers. They are very common in older homes and in landscape lighting. These loads are generally not dimmable. When using a magnetic core transformer, you should never underload the transformer. It's best to load it with at least 70% of its maximum load rating. If rated at 600 watts, it should have at least a 420-watt load attached to it. Replace burnt-out bulbs quickly to avoid underloading. Underloaded magnetic transformers can cause bulbs to fail prematurely. If a burnt-out bulb is not replaced quickly, all other bulbs on that circuit may soon burn out as well. Electronic state transformers are the newer type of transformer. They require reverse phase dimming. If used with a forward phase fixture or load, there will be poor dimming performance and flickering, buzzing from the bulb itself, and damage to the dimmer and/or the transformer. It is more efficient, smaller, and lightweight than the older magnetic core transformers, but they are more expensive and they have a risk of high inrush current. Load types. Incandescent bulbs can be used with forward and reverse phase dimming. They can have a high inrush current if they are turned on when cold. When used with an adaptive phase dimmer, reverse phase will generally be used as it generates less audible noise. Some incandescent bulbs have been phased out due to inefficiency because they generally create more heat than they do light. However, there are newer generations of incandescents that are a lot more energy efficient. Halogen bulbs are incandescent bulbs filled with halogen gas. They generally have a higher luminosity and color temperature, and they're smaller in size and more efficient. Fluorescent bulbs. Fluorescent bulbs are connected to a ballast within the fixture. Whether or not that fluorescent bulb can be dimmed is dependent on the ballast itself. Most of the inexpensive ballasts are not dimmable. Most fluorescent lights have a minimum level in order to ignite or stay on. That level is usually between 5 and 20%, which can be handled by a control signal with 0 to 10 volt dimming or high lume dimming, or can be managed by setting the minimum on and cold start levels within the Control4 dimmer. Most fluorescent bulbs have a high inrush current, which can result in lower wattage rating. There are ballasts for all dimming technologies: phase cut dimming, 0 to 10 volt dimming, high lume dimming, and Dolly DSI dimming. There are also magnetic ballasts that can be used with fluorescent bulbs. These are not to be confused with the magnetic transformers that we previously discussed. Control4 dimmers are not rated to be used with magnetic fluorescent ballasts. If one is found in a retrofit scenario, the ballast should be replaced before attempting to connect it to a Control4 dimmer. Compact fluorescent bulbs. Compact fluorescents, or CFLs, fall into two main categories, those with a separate ballast or an integrated ballast. Separate ballast CFLs require an external ballast within the fixture. Generally, they have the same characteristics of fluorescent bulbs and follow the same guidelines. Integrated ballast CFLs have the ballast integrated into the bulb itself instead of in the fixture. Many are not dimmable and should not be used with a dimmer. Those that are dimmable will explicitly indicate so on the box. The dimming performance of CFLs varies widely. Use the minimum on and max on levels within the dimmer properties for best results. Generally, there are no guidelines on the preference between reverse and forward phase dimming when using a CFL, though it's recommended to use with the adaptive phase dimmer in order to choose between the two. Compact fluorescents have a high inrush current, like fluorescent lights. Therefore, their maximum wattage rating is lowered to account for it. It is recommended to use the equivalent to wattage when making calculations with CFLs. Generally, a 14-watt CFL is equivalent to a 60-watt incandescent bulb. Light-emitting diodes, or LEDs. As fluorescent lights used a ballast, LED lights require a driver. LEDs are inherently dimmable depending on the driver used with the LED bulb. LEDs are still a new technology. Performance, dimming capability, brightness, and color temperature can vary from bulb to bulb and manufacturer to manufacturer. The dimming range could be limited, ghosting in a fully off position. Identical LED bulbs may also have different minimum on levels, flickering at low levels, or an audible noise when on. Most LED bulbs also suffer from dead travel, maxing out in brightness before they reach 100%. LEDs fall in two main categories, separate driver and integrated driver. Separate driver LEDs are equivalent to fluorescent lights, or the separate ballast CFLs. It requires that the fixture itself has the driver internally. Separate driver LEDs require a specific fixture type, requires low voltage, and follows the same guidelines as fluorescents and separate ballast CFLs. Integrated driver LEDs include the driver within the bulb itself. They can be installed as a replacement bulb with line level voltage. The driver within the bulb determines the type of dimming required and the performance of the dimming. Test these LED bulbs with both forward and reverse phase dimming to determine the best performance. There is usually a trade-off between audible noise and the ramping range. LEDs have a high repetitive peak current. It's like the high inrush current, but this time it happens on every cycle, not just when the bulb turns on. This affects the number of LED loads on a single circuit. Too many LED bulbs with high peak currents can trip circuit breakers. Control-4 dimmers have a 120-watt maximum for LED bulbs. When using LEDs, the best practices are to use them with control signal dimming, like 0 to 10 volt dimming. If phase cut dimming is required, always wire an LED fixture with a neutral, and generally, reverse phase is better, therefore use with the adaptive phase dimmers. And if you log into the dealer portal, dealer.control4.com, and go to the support page, use our lighting compatibility table to find the LED, CFL, and magnetic low voltage bulbs that are recommended by Control4. Motors. Control-4 dimmers are not rated nor designed to control motors. Connecting a dimmer to a motor can burn out the dimmer or the motor or both. Motors can be wired to a Control-4 switch or relay module, to the Z2 I/O, or to the heavy-duty relay. Check the specifications for these devices to ensure compatibility. This concludes Module 2.